Hello everyone. My name is Hiruna Akshika Vijayakorn and I am representing Group D12 from the Faculty of Engineering at the University of Moratuр. Today we are presenting our project the Sri Lanka Landslide Early Warning System. The purpose of this project is to use modern technology to solve a very old and dangerous problem in our country. We have focused our work on three main pillars: smart monitoring, timely alerts, and safer communities. Over next few minutes, I will walk you through how we plan to use cloud computing and satellite data to protect lives and property in landslide prone areas. Let's begin with the background of this project. As many of you know, landslides are one of the most common and destructive natural hazards in Sri Lanka, especially in central highlands. The risk is created by combination of two things. First, the heavy rainfall we experience during monsoon seasons, and second, the unstable slopes that characterize our mountain regions. Unfortunately, the disaster risk for people living in these areas are increasing while these are existing warning systems. They are often expensive to set up and very difficult to maintain in remote areas. This is why our project proposes a cloud-based, cost-effective alternative that can be accessed more easily. On this slide, we look at the specific challenges we face today. We have identified three main problems that current systems struggle with. First, there is a weather interference. Many traditional optical satellite systems cannot see through heavy cloud cover since landslides usually happen during heavy rain and clouds. Uh, these systems often fail exactly when we need them most. Second, we have economic constraints. Ground based sensor systems are very accurate, but they require high installation and maintenance costs that are hard to sustain. Finally, there's a research gap. We realize there is a real need for a solution that is low cost, fully automated, and works in all weather conditions. Our projects aim to fill this gap by using satellite rainfall data, digital elevation models (DEM), and cloud computing technologies. So, what exactly we are trying to achieve? We have set four main objectives for this system. The first is to detect high risk landslide zones automatically without needing a manual labor. Second, we want to analyze the relationship between rainfall intensity and terrain slope to understand the science of the risk. Third, we aim to generate early warning alerts that can reach people in time to move to safety. And fourth, we want to provide visual risk mapping through interactive GIS dashboards for decision makers. These benefits are clear. We want to reduce disaster related damages, improve the overall safety of our communities, and better tools to our disaster management authorities. To make this system a reality, we have defined a set of strict requirements. On this screen, you can see our functional requirements table. These include the automated collection of rainfall data, slope analysis of the terrain, identification of risk zones, and providing a visualization for the user. But we also have non-functional requirements. For a safety system, reliability is everything. So especially during the monsoon season, the system must process data in near real time so that the alerts aren't late. It also must be a low cost and have a scalable architecture uh, so that it can be expanded to cover more cover more districts in the future. Let's look at the methodology behind our work. We use a process called multi-criteria evaluation or MSC. This is scientific way to look at the different factors at the same time. We especially look at the rainfall intensity, the steepness of the terrain slope, and the threshold analysis to see if the condition have reached a dangerous level. As you can see in the workflow at the bottom of the slide, the process is very structured. It goes from data ingestion to slope analysis, then to risk validation, and final to alert generation. This ensures that every alert is based on real calculated data. This slide shows the technical engine of our project. Please follow the flowchart with me. We begin with we begin with satellite rainfall data. This raw information is sent to the Google Earth Engine, which is a powerful cloud platform for geographic data. Inside this engine, we perform the terrain and slope analysis. The system then checks this against our risk thresholds. And next, if the data shows a high risk, the system updates the GIS dashboard for visualization and pushes out early warning alerts to the necessary people. This cloud-based approach means we can process huge amounts of data very quickly without needing a physical server on site. On the slide, we can see what the final output will look like for this user. We are developing a dynamic GIS dashboard that uses color-coded indicators. The markers will signify high risk zone where a landslide is very likely, while blue markers will show moderate risk areas that need monitoring. Because we want to start where the need is greatest. Our primary target areas are the Badulla district and the Nuwara Eliya district. These areas have historically suffered the most from landslide, and we believe our system can make the biggest difference there. In conclusion, the Sri Lanka landslide early warning system is more than just an engineering project. It is a solution designed to protect our neighbors and our land. By using cloud technology and satellite data, we have created a system that is smart, timely, and most importantly, affordable for our country. We believe that by working together with disaster management authorities, we can significantly reduce the impact of these natural hazards. Thank you very much for listening to our presentation today. We hope this project contributes to a safer Sri Lanka. I am now looking forward for your feedback and any questions may have. Thank you.